Hello students, my name is Sumit Sagar Hota. I am a PMRI PhD student at IIT Palakkad. Today we are going to discuss lecture 41 to lecture 45 by Professor Ashok Desar, IIT Kanpur, of the subject Introduction to Airbreathing and Propulsion by NPTEL. This is the week 9 of the live discussion section. In this section, we will see some of the theoretical questions and then at the end we will solve some of the numerical problems. Okay. So now enough of waiting. Let's start the section. The first question is the Navier-Stokes equation is the conservation of dash. Okay, we know very well the Navier-Stokes equation is always the conservation of what? Momentum. Okay. Conservation of momentum. Okay. Centrifugal compressor is an dash. Okay. Centrifugal compressor is an the thing is this is a kind of exceptional question. Okay. So it's actually in most of the cases all types of compressors are always irreversible. Okay, so there will be some losses. But for the centrifugal compressor, in some cases, exceptional cases, it can be reversible. Okay, so this question actually asks about that reversible process into account. Okay, so you can tell that the answer is C. Reversible process under some circumstances. Okay. In centrifugal compressor, flow is dash. Okay, we know always in a centrifugal compressor, the flow is always a radial flow. Okay. Okay. In centrifugal compressor, the centrifugal energy present in the gas is utilized to dash. Okay. Okay, is equal to utilize the work to do is utilized to do the work. Okay, and that work is what? That work is to compress. Okay. Which is to what? Compress. Okay. The centrifugal compressor delivers dash flow capacity. The centrifugal compressor delivers low flow capacity. Okay. Rotating speed of centrifugal compressor is dash function of diameter to be maintained. Okay. Okay, the rotating speed is always inversely proportional to the what? Diameter. Okay. Of the centrifugal compressor. Okay. B rotational of what? centrifugal compressor is inversely proportional to 1 by diameter. Okay. Of so answer is A actually. Hmm. Om Namah Shivaya. Okay, so dash has large change in inlet to exit radius when compared to centrifugal compressor. Okay. So they ask about the what is the type of compressor we have to tell. Okay. Okay. So for all kinds of either it is a centrifugal or it is axial, there will be a change in between what the inlet and exit radius. Okay. So they are asking is axial compressor having higher inlet to exit radius or not? Okay, so that's the question. So answer is yes. Axial compressor having larger change in the inlet to exit radius. Okay, because of the type of flow of the compressor. Okay. Okay. Okay, so the first part in both centrifugal compressor and axial compressor are similar. True or false? Answer is A, which is true. Okay. So the first part. Okay, so the centrifugal compressor dash the energy by increasing the radius. Okay. That means they are asking about the relation between the energy and the radius. Okay. Okay. So answer is B. Okay. Why B? Because it's inversely proportional. Energy is inversely proportional to the radius. Okay. Um, Radius of centrifugal compressor or fan. Yeah. Okay. So what the next? We just go. The centrifugal compressor increases the density of fluid more than dash. So this value, if you remember it, you can just answer this question. It's actually 5%. Okay. It's a kind of error. This much density it can increase. Okay. There will maybe plus or minus. Some values will be plus or minus 1% will be there. Okay. When the density increases, okay, by centrifugal compressor. नहीं भाई इसमें छोड़ नहीं भाई कोई कुछ इसमें हमने छोड़ दो centrifugal fan has relative fluid velocity of dash. Okay. It's less than Mach 0.3. Okay. Okay. So what is the pressure coefficient of a centrifugal compressor? Derive that. Okay. 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 So this kinds of question is a derivative derivation kinds of question. Okay. So you should know how to derive all these expressions. Okay, and yeah, you just also going to remember this value. What is the value of pressure coefficient? Okay, for a centrifugal compressor. Okay, that can be helpful in your numericals. Okay. So the pressure coefficient of the centrifugal compressor okay, so the pressure, what is the pressure coefficient? So the pressure coefficient of the centrifugal compressor represented by psi p. Okay, so to prove psi p equal to 1 minus phi 2 into cot beta 2. So psi p is your what? Pressure coefficient phi 2 is your flow coefficient and beta 2 is your blade angle at outlet. Okay. Now what is psi p? So psi p is your pressure coefficient is equal to H by U2 square by G. Okay. And what is H? H is equal to heat developed. Okay. Is equal to VW2 U2 minus VW1 U1 divided by G. Okay. For centrifugal compressor, VW1 is equal to 0 and V1 is equal to VF1. Okay. These are the two conditions we know already for a what? Centrifugal compressor. Okay. So substitute and find out H value. Okay. So in the expression, if Vw1 will be 0 and V1 is equal to Vf1. Okay. So what is Vw2 value? Okay. So Vw2 you know always. So Vw2 is equal to U2 minus Vf2 into cot beta 2. Okay. Okay. So so this is let it be equation number 1 and this will be equation number 2. Okay. So let it be 3. Let it be equation number 1. Okay. 1, 2 and 3. So we have to substitute 2 and 3 in equation number 1. Okay. Substituting 2 and 3 in 1. We get so H is equal to U2 minus Vf2 into cot beta 2 into U2 divided by G. Should we say it? Okay. And okay. Now what is your psi p? Psi p is your H by U2 square by G. Okay. Psi p is equal to H by U2 square by G. Okay. Is equal to U2 minus Bf2 cot beta 2 into U2 divided by G into U2 square by G. This is G get cancelled, U get cancelled. Okay. So yeah. So now if you just solve it, you will get psi p is equal to u2 minus vf2 cot beta 2 by u2. Okay. So just take u2 common from numerator and denominator and just cancel it out. Okay. So is equal to u2 1 minus vf2 by u2 cot beta 2 by u2. So u2 get cancelled. Okay. So psi p is equal to 1 minus vf2 by u2 cot beta 2. Okay. We also know that the your angle phi 2 is also is equal to, okay, is since phi 2 is more or less equal to vf2 by u2. Okay, we can just substitute here. Okay, so psi p is equal to 1 minus phi 2 into cot beta 2. Now proved. Okay. Now read this question and try to solve. Okay, I think you solved the question. Now just see how I am solving this question. Okay. So first of all, we should do the velocity triangle. Okay. Because for these types of question, especially the compressors, okay, centrifugal compressors, we need the velocity triangle first. Okay. BR1, this is your B1, this is your U1. Okay. And this is your phi, BR2, BW2, BF2, beta, and V2. Okay, and this is your U2. Okay. Okay, so let's write down what are the things given. So D2 is your 30 centimeter, pi W 1.04, pi S is 0.9, and D1 is your 15 centimeter. Okay. N is your 15,000 RPM, M dot is your 18 kg per second, T1 is your 295 Kelvin, and isentropic efficiency is 0.78. V1 equal to Vf1 is equal to Vf2 is 150 meter per second. Okay. So let's draw the TH diagram for the process 1 to 2. Okay. Okay. So yes, let's go for now solution. So T2s by T1 is equal to Rp to the power gamma minus 1 by gamma. So U2 is equal to pi D2n by 60 is equal to pi into 0.3 into 15,000 divided by 60. So U2 is equal to 235.5 meter per second. Okay. I don't know if I can. Okay, so let's find out the power required to drive the compressor. Okay. This is your answer. Okay. So we also know that P is equal to mCp delta T. Okay, m dot Cp T2 minus T1. Okay, so substitute and find out the value of T2. Okay, P is equal to m dot Cp T2 minus T1. Okay, equal to 0.94 into 10 to the power 3 is equal to 18 into 1.005 into T2 minus 295. So T2 is equal to, if you solve it, you will get T2 value as 347 Kelvin. Okay. Okay. So we have T2 value now. So we need to find out the value of T2s. Okay. This we need to T2s value we need. Okay. That means the actual temperature T2 we already have. Just we need to find out the isentropic temperature T2s. Okay. For that, we just applied the isentropic efficiency relation is equal to 0.78 is equal to T2s minus T1 divided by T2 minus T1. T2s is equal to 295 plus 0.78 347 minus 295. T2s is equal to 335.56 Kelvin. So now we need to find out what the RP value. Okay, the pressure ratio RP you need to find out. Okay, so T2s by T1 is equal to RP to the power gamma minus 1 by gamma. T2s by T1 to the power gamma by gamma minus 1. Okay, so substitute the value and find out the value of RP. Okay, 335.56 by T1 is 295. रेडी रहेगा उसके लिए. So RP is 1.56. पता नहीं क्या बोलना है. गान मराना जानते हो नहीं जानते समझ पा सुनो. So you see now we have RP. Okay, let's find out the E1. Okay, from the E1 we just need to find out the theta. Okay, okay, let's find out the E1. The E1 is equal to pi d1 n divided by 60. Okay, so pi into 0.15 into 15,000 So this is your u1. Okay, so theta is your what? Theta is your vane angle at root, and phi is your vane angle at I. Okay. So tan theta is equal to V1 by U1. Okay. Is 150 by U1 is your what? 117.75. Okay. Oh, yes. What is theta then? Theta is equal to tan inverse of 150 by 117.75. So theta is 51.86 degree. Okay. 51.86 degree. This is your answer 3. Okay. Okay. What is phi s? Okay, let's find out phi s. So phi s is equal to Bw2 by U2. So implies Bw2 is equal to phi s into U2. Okay. Phi s is your 0.9 into 235.5. Okay. So Bw2 is equal to 211.95 meter per second. Okay. So now we have what? Bw2 we have, right? Just let's find out the tan phi. Okay. So tan phi Bf2 divided by U2 minus Bw2 is equal to 150 divided by 235.5, 211.95. So phi is equal to tan inverse of 150 by 235.5 minus 211.95. Okay. Equal to, okay, if you solve it, you will get the value as phi is equal to 81 degree, 81.07 degree. Okay, answer. Mm. Okay, so this is the answer, right? Uh, one more things. Anything left? No, nothing left. Everything over. Okay. So. Okay, so the question, in the question they asked the total head pressure ratio. Okay, head pressure ratio they want. Okay, okay, and the second bit is the power required. Okay, so power required we got from here. Then head pressure we got from here, RP. Okay, then theta is also the exit angles there. Okay, sorry, the inlet angle of the vane at the root and the tip impeller eye. Okay, the power required. Okay, everything we have. Okay, the inlet angles we have. Okay, theta and phi we have. Okay. Here is the theta and this is the phi. Okay. हाँ, 10 मिनट से बढ़ाने टाइम हो Okay, so this question is this first we did the question. A gas turbine utilizes two-stage centrifugal compressor. The pressure ratio of the first and the second stage are 2.5 and 2.1 respectively. The flow of air is 10 kg per second. This air being drawn at 1.013 bar and 20 degrees Celsius. If the temperature drop in the intercooler is 60 degrees Celsius and the isentropic efficiency is 90% of each stage, then calculate the actual temperature at the end of each stage and the total compressor power. Okay. So for this type of question, first of all, always you do the TS diagram. You should need to do. Okay. First draw the TS diagram. This is your T4. This is your T2. Okay. Okay. So P1 T1 and this is your P2 and T2S. Okay, this is P2 T3 and P3 T4S. Okay, as for the isentropic process. Okay. So okay, let's write down what are the things given. M dot is your 10 kg per second. P2 by P1 is equal to 2.5. P3 by P2 is your 2.1. P1 is 101.3 kilopascal. T1 293 Kelvin. Okay. So T2 minus T3 is your what? 60 degrees Celsius, and isentropic will be 0.9. Okay, so let's solve it. Okay, so T2S is equal to T1 into P2 by P1 to the power gamma. Okay, so so 293. So what is T2S? So T2S is your 380.68 Kelvin. So what is the isentropic efficiency? The isentropic efficiency is equal to 0.9 is equal to T2S minus T1 divided by T2 minus T1. So find T2 from here. T2 is equal to 293 plus 380.68 minus 293 divided by 0.9. Okay. If you solve, you will get the T2 as 390.43 Kelvin. Okay. This is your answer of bit 1. Okay. Okay. भाई इतना मैं नहीं बोलता, सॉरी, मैं बहुत कम बोलता हूँ, इतना बोलने का मेरे पास टाइम नहीं है. Okay, so T2 minus T3 is equal to 60. Okay, so what is this? 390. Okay, so T2 you know, T 390. Okay, so just put it. Okay, 390 put 43 minus T3 is equal to 60. Huh? So what is T3? T3 is equal to then 330.43 Kelvin. Okay, so we have now T3 also. Okay. So what we else need? We now need T4S. Okay. How we will find out? Just give what? T4 by T3 and P3 by P2 relation. Isentropic relation you need to apply. Okay. So by isentropic relation, the T4S is equal to T3 into P3 by P2 to the power gamma minus 1 by gamma. Okay. Because why? Because you know the pressure is constant. Okay. Throughout. Okay. So P2 equal to P3. Okay. P2 equal to P3 pressure and P3 equal to P4 pressure. Okay. So just take the pressure ratio value and put it and find out the value of T4S. So 330.43 into 2.1 into 0.4 by 1.4. So T4S is your 408.45 Kelvin. Okay. This is your T4S. Uh-huh. So what is T4 now? So T4 is equal to T3 plus T4S minus T3 by 0.9. Okay. Okay. So what else we need? We need now compressor power. Okay. Let's find out the compressor power. This is equal to m dot Cp T2 minus T1, okay, plus T4 minus T3. Okay. This is the question. Okay. So it is what? 10 into 1.005 390.43 minus 293 plus 417.12 minus 330.43. Okay. Suppose 1850.406 kilojoule. This is your answer. Okay. What the question asks, the total pressure, total compressor power, the actual temperature at the end of each stage. Okay. End of each stage means all the temperatures we need. Okay. We calculate all the temperature T4S, T3. Okay. Okay. T2, everything we calculated. Okay. So, yeah. This is your second bit. With this, we end the section. Thank you very much for attending the section. If you have any doubts, you can ask in my YouTube channel. My YouTube channel is Sumit Sagar Hota. Thank you very much for attending. And if there is any doubts, you can ask in my channel in the comment sections. See you in the next week again in 6 to 8 p.m. Have a nice day and good night. We'll meet with the next lecture 10. Okay. Thank you.